Hi, welcome to MATCOM. In this particular video, we will be discussing one important question from the chapter Solutions in Chemistry Class Plus 2 NCERT textbook. The question has been completed in one line or two lines, but in order to interpret this particular question or in order to solve the question, we need to go through many steps. First, we'll try to understand the question. Before that, we will try to inform you that there are various playlists that are available in our channel related to class 9, 10, plus 1, plus 2, physics, chemistry, mathematics. The videos are uploaded in Malayalam as well as in English. There are some other videos associated with the quantitative aptitude and reasoning, Indian polity. Some general topics are also being discussed in the channel. So please see those videos. If you are interested, please like to those videos, share with your friends as well as subscribe to our channel. So the question is, how many ml of 0.1 molar HCl are required to react completely with 1 gram mixture of sodium carbonate and sodium bicarbonate containing equimolar amounts of each? That means we have a mixture of sodium carbonate and sodium hydrogen carbonate or sodium bicarbonate. The total weight of this mixture is 1 gram. They have specifically mentioned that both are equimolar solution. That means the number of moles are same. Equimolar solution. Then we are allowed to react with the 0.1 molar HCl. That means one acid is allowed to react with the base. So what is happening? Neutralization is happening here. So we need to find out how many ml of 0.1 molar HCl can react with the 1 gram sodium carbonate and sodium hydrogen carbonate mixture. Both are equimolar in nature. So we don't know the exact weight of sodium carbonate or sodium hydrogen carbonate. The total weight is 1 gram. So we can assume that the weight of the sodium carbonate, let it be x gram. Therefore, the total weight is 1 gram. Therefore, the weight of sodium hydrogen carbonate is going to be 1 minus x gram. 1 minus x gram. So when you're considering sodium carbonate, we can calculate the molar mass of sodium carbonate. The molar mass of sodium carbonate is 2 into 23 because 23 is the atomic weight of sodium. We have 2 sodium plus carbon is 12, oxygen is 16 into 3. So in total, it will become 106 grams per mole. It will be 106 grams per mole because 23 into 2, 46. 46 plus 12 is 26 plus 46. 46 plus 12 is 58. 58 plus 48, that is equal to 106 grams per mole. If you calculate the molar mass of sodium hydrogen carbonate, sodium is 23, hydrogen is 1, carbon is 12, oxygen is 3 into 16. 16 into 3, 48. 48 plus 12 is equal to 60. 60 plus 24, that is equal to 84 grams per mole. So we got the molecular weight of sodium carbonate as well as we got molecular weight of sodium hydrogen carbonate. So they have given the weight also. If the weight is given, we can easily calculate number of moles. So the number of moles of sodium carbonate, number of moles is equal to given weight by molecular weight. What is the weight of sodium carbonate? That is X divided by molecular weight, that is 106 grams per mole. Okay. Then what is the number of moles of sodium hydrogen carbonate? Number of moles of sodium hydrogen carbonate, that is equal to the given weight, that is 1 minus x gram divided by molecular weight, that is equal to 84 gram. In the question, they have very specifically given that they are equimolar solutions. Equimolar solution. What do you mean by equimolar solution? It means that number of moles of sodium carbonate is equal to number of moles of sodium hydrogen carbonate. Number of moles of sodium carbonate equal to number of moles of sodium hydrogen carbonate. So we can equate number of moles of sodium carbonate with the number of moles of sodium hydrogen carbonate. Okay, fine. So if you are equating both, you will get X divided by 106, that is the number of moles of sodium carbonate, equal to 1 minus x divided by 84. If you cross multiply, you will get 84x equal to 10 into 1, that is 10 minus 106x. If you take x to the one side, it will become 106x plus 84x equal to 106x. That is 106 plus 84 equal to 190x, that is equal to 106. Therefore, x is equal to 106 divided by 180. So you will get 106 divided by 190, you will get it as 0.558 grams. So if x is 0.558 gram means 1 minus x will be equal to 1 minus 0.558. 1 minus 0.558. So this is going to be 0.442 grams. 0.442 grams. Clear. So then we can calculate the number of moles. So how we can calculate? So the weight is obtained. Therefore, the number of moles of sodium carbonate will be equal to given weight, that is x, that is 0.558 grams divided by molecular weight, that is 106. So you will get it as 0.00526. This calculation you get right up. There is no need of any explanation from my side. So we got the number of moles of sodium carbonate. So when you're considering the neutralization reaction, we are speaking about neutralization reaction between HCl and sodium carbonate, as well as between HCl and sodium hydrogen carbonate. So when you are considering sodium carbonate reacts with the HCl, gives sodium chloride plus water plus carbon dioxide. Because it's a neutralization reaction, acid react with the base, you will get a salt. So if your carbonates are reacting with the acid, you will get carbon dioxide and water, along with it, you will be getting a salt. So if you want to balance it, we have 2 sodium carbonate is there. So give 2 NaCl. Then when you're counting hydrogen number, 2 hydrogen, here there is only 1 hydrogen. So what you can understand, 1 mole of sodium carbonate react with the 2 moles of HCl. 1 mole of sodium carbonate react with the 2 moles of HCl. The same way, if you're considering the reaction of sodium hydrogen carbonate with HCl, sodium hydrogen carbonate with HCl will give you sodium chloride plus water plus carbon dioxide. If you check, you can understand that 1 mole, is it balanced? Yeah, sodium number is balanced, hydrogen is 2, 1 plus 1, 2, carbon, yeah, balanced. That means 1 mole of sodium bicarbonate react with the 1 mole of HCl. So what you can understand, 1 mole sodium carbonate reacts with the 2 moles of HCl. 1 mole sodium hydrogen carbonate reacts with the 1 mole of HCl. We have calculated that in reaction mixture, we have Na2CO3. The number of moles of Na2CO3 is 0.00526 is the number of moles of it. We have calculated at the top. See, 0.0526. The number of moles of sodium carbonate is 0.0526. In the question we have very clearly says that number of moles of sodium carbonate equal to number of moles of sodium hydrogen carbonate. Therefore, number of moles of sodium hydrogen carbonate also equal to 0.0526 moles. From the balanced equation, we came to understand that 1 mole sodium carbonate react with the 2 moles of HCl. That means 0.00526 moles of sodium carbonate reacts with 2 into 0.0526 moles of HCl. In the same way, 1 mole of sodium hydrogen carbonate react with the 1 mole of HCl. That means 0.00526 moles of sodium hydrogen carbonate reacts with 0.00526 moles of HCl. Moles of HCl. That means for this particular reaction, that means x gram of sodium carbonate and 1 minus x gram of sodium hydrogen carbonate will react with 3 into 0.00526 moles of HCl. This is equal to 0.01578 moles of HCl. How do we get this? From the balanced equation we understood 1 mole of sodium carbonate react with 2 moles of HCl. Here we have 0.00526 moles of sodium carbonate that will react with 2 into 0.00526 moles of HCl. Clear? So in the same way we did for sodium hydrogen carbonate also. Total we require 0.01578 moles of HCl. Moles of HCl we require. Clear? What we have? Now in our mixture we have 0.1 molar HCl. 0.1 molar HCl. What is molarity? Molarity is the number of moles divided by volume of solution in liters, or number of moles in 1000 ml. Number of moles in 1000 ml. That is 0.1 molar solution means 0.1 moles of HCl. 0.1 moles of HCl in 1000 ml solution. 0.1 moles of solution in 1000 ml. That means 0.1 mole is present in 1000 ml of solution. How much mole we require? We require 0.01578 moles. That means if 10 apples cost 50 rupees means 5 apples cost 50 divided by 10 into 5. In the same way, 0.1 mole is present in 1000 ml means 0.01578 moles is present in 1000 divided by 0.1 into 0.01578 is equal to 157.8 ml. How can you simplify this? Here it is 0.1, 1 by 10 it will go up. That will become 10 raised to 4. 10 raised to 4 into 0.01578 is equal to 157.8 ml. This is the way in which you need to solve this particular question. That means in this particular question they asked you to calculate the number of moles of how much ml it is required. That is 157.8 ml of 0.1 molar HCl is required in order to react 1 gram of sodium hydrogen carbonate mixture, which is equimolar in nature. Equimolar in nature means number of moles of sodium carbonate equal to number of moles of sodium hydrogen carbonate in that particular mixture. Hope the explanation is clear. If you need any clarification, do let me know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. If you are interested to see explanation regarding any specific question or any specific topic, that can also be commented. Keep watching, keep learning. Thanks for watching. Bye.